Chapter 9, we'll be learning about transformations. There's lots of different types of transformations. There are reflections, where we have two images that are reflections of each other. This one's called a translation. It's just a slide. This one is a rotation. You can sort of imagine those birds pivoting around a point. And this one, if it enlarges or shrinks down, that's called a dilation. And today we're focusing on translations. We'll start with coordinate notation, where the pre-image and the image are graphed on a coordinate plane. You could take note that the pre-image is the original shape, and the image is the new one after the translation. How can you tell which is which? Do you see how these have just regular capital letters labeling those points? That's the original, so that's the pre-image in this case. Where when it switches to having those little apostrophes, we call those primes. I would read that as D prime. We can tell that that's the new image after the translation. So the main way you'll be able to tell is that the pre-image will have just the regular points and the image will have the primes. Since this top one is the pre-image, we are going to imagine this sliding down here, and that would be the translation. The translation is just the slide of one shape to another. And we want to be able to describe that in coordinate notation. Let's just look at a couple coordinates. Point D is at the point 8, 8, and point D prime is at the point 10, 3. So you can see that the 8 slid over to 10, and the other 8 slid down to 3. Because x is left and right and y is up and down, and 8 sliding right to 10 would be like adding 2, and 8 sliding down to 3 would be like subtracting 5. So you should find that for every point on this shape, if we add 2 to the x and subtract 5 from the y, it should move it right 2 and down 5. So to describe that in coordinate notation, we are going to talk about x comma y, that being the pre-image. And then we're going to write an arrow and we're going to tell what happens to each x value. Well, since each x value gets moved to the right by 2, we'll write x plus 2. And then each y value gets moved down by 5, so the y value will transform into y minus 5. And again, all that tells us is that we are moving right 2 and down 5 for every ordered pair. On the next example, can you tell which one is the original? Which one is the pre-image? The pre-image is the one that has just the regular letters, segment RS. And so segment RS slid or was translated to segment R prime S prime. And then we would say that that is left and up. And we're going to try to describe that in coordinate notation. So if you look at point R, it has an x and a y value. What happens to its x value and what happens to its y value? That's what we want to write for our coordinate notation. Well, to the x value, it moves 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the left. So that would be x minus 9. Left is minus. And then once r moves to the left, it just needs to move up a square, right? So up a square would be like a plus 1. And that'll work for every point on that segment, including the other endpoint s. It will wind up at s prime. So that's how we describe a translation using coordinate notation. Here I've got a pre-image of triangle ABC, and we're going to find out what happens to each of those vertices if we translate by the rule xy moves to x plus 5, y minus 3. So there's a couple of ways we could look at this. We could take each x value and add 5. And then we could take each y value and subtract 3. And that gives us 3 new ordered pairs that I would label A prime, B prime, and C prime. And what was the movement like in that translation? Each point went down 3 and right 5, which is supported by this minus 3 for the up and down and the plus 5 for the left and right. Plus 5 meaning right, -3 meaning down. I'd also like to explain what is meant by an isometry. I don't know if you noticed, but when you do a translation, the pre-image and the image are congruent to each other because all we're doing is sliding. Segment RS would be congruent to segment R prime S prime. Their lengths would be the same. So we say that all translations are isometries because the pre-image and the image are congruent. Another way to describe a transformation is by using a vector. So let's just do a quick run through of what is a vector. A vector is normally shown by drawing a little arrow. And it's not an arrow like a ray, it's not infinite, it has a certain length. That certain length tells what its magnitude is, and then the arrow obviously shows the direction. So vectors are just things that have direction and magnitude, like forces or the velocity of the wind. Sciencey things like that. They show up a lot in physics. But to me, they remind me a lot of translations because we always slide our pre-image in a certain direction by a certain amount in a certain direction and magnitude. So if we were talking about vector BC down here, if we slid from B to C, we would be sliding down 2 and right, looks like 9. And so if we were going to talk about vector BC, we can talk about it in component form. Instead of using parentheses, we're going to use these pointy brackets. They almost look like V's, right? V for vector. And the component form of this vector is going to show that it goes down 2 and right 9. Now it'll have an x and a y value just like an ordered pair. Do you suppose the x value would be the down or the right? We know the x-axis goes left and right, so a right 9 would be denoted by a positive 9x value. And then for the y value, we know y values, the y-axis goes up and down. So if we wanted to use a down 2, we would use -2 for the y value. This is called the component form of the vector, and it just tells us to move right 9 and down 2. So here I've got a triangle with vertices at A, B, and C, and I'm being asked to translate that using the vector 5, -1. Remember that the x value tells us right and left, and the y value tells us up and down. So from this I can tell that I'm going to go right 5 and down 1. So each of those points, I just go point by point and go right 5, down 1, and that's where my new point is. I'm going to call it A prime. Each point goes right 5 and down 1. Right 5 and down 1. And so here's the image, A prime, B prime, C prime. And a great way to check your work is to check to see, does it look like an isometry? Does it look like triangle ABC is congruent to triangle A prime, B prime, C prime? If they don't look congruent, that means you made a mistake somewhere, because translations are always isometries. So just a little review here. We want to describe this translation in 3 different ways. And with all 3 types of descriptions, you're going to want to identify which one was the pre-image and which one is the new image. On this one, I can tell that ABC here is the pre-image. It has the original ABC, and that helps me see that the translation went sort of in this direction. That little arrow is actually the vector. So how would we describe this in words? I would say that it goes up 1, left 4 for each point, right? Up 1, left 4, up 1, left 4, up 1, left 4. Remember, in coordinate notation, we talk about the pre-image having points at x, y, and then what would happen to the x and what would happen to the y at each vertex. Is it the up or the left that is going to affect my x value? Remember, right and left is the x-axis, so it'll be x. +4 or -4 for a left 4? -4 means moving to the left. And so then the up 1 is going to show up on the y value. Up 1 is +1. And then if I wanted to use a vector to talk about that same translation, remember I used the pointy brackets, and it should remind you a lot of coordinate notation. The left 4 is denoted by a -4 for the x, and the up one is denoted by a positive 1 for the y. And we can see that nothing changed in length and nothing changed angle-wise, so the pre-image and the image are congruent. Remember, that tells us that we have an isometry. Isometry means congruent, or a congruence transformation. And that is translations, our first type of transformation.